In today's lesson, we are going to be looking at types of data. Right? So before we just kind of looked at a brief introduction to data, looking at some key terms and concepts. Now we're going to be looking at different types of data. So as a warm-up, I want you to read through and look at each of the following graphs and describe one conclusion that you can take from it. So reading through it, what's one kind of conclusion that you can take from the graph? So the first one, out of the people who reported incidents on racial profiling in Ontario in the last 12 months, the following was found. I'll zoom in a bit so you can kind of see it. Again, just kind of take a second, read through it, and then ask yourself, what's one conclusion that you can take from this? Next one we're looking at the age of first-time mothers in 1980 versus 2016. So again, take a look at our graph or representation. Think about what is one conclusion that you can take away from it. There may only be one, there may be multiple, right? You can think of different aspects of what we're looking at. There's no right or wrong answer really, unless you're talking about something that's not represented. But think about what's one thing that you take away from looking at this. Next one, for each of the students surveyed for the amount of time it takes to get to school, they were then asked how many absences they had. So we're looking at the amount of time it took to get to school, and the time, and the absences. So think about what's one conclusion, again, that you can take away from this. Looking at tobacco purchases in teens over time from 2011 to 2018. Looking at middle school and high school. Looking at any product, e-cigarettes, in the different ages. So again, what's a conclusion that you can take away? Looking at the average or the monthly average price for a dozen eggs since 2000. Again, what can you take away? This one's a little different. It might take a little bit of a while to look at, and I'll zoom in on it because some of the numbers might be small. But looking at the proportion of where people make friends versus the income rank. So looking at it, basically the line or the bars represent the proportion of where you make friends. You kind of see the average proportion, right? You see 2.4 times more likely than average. Right? And we have our different income levels. The 100th would be the high income, 5th would be low income. We're looking at in high school, in college, at work, and in the neighborhood. Right? So what conclusions can you make based on this? Maybe come up with a reason of something. Why do we see this? It's easy to figure out the conclusion or to come up with a conclusion. Think about why might that be the conclusion, or why might we see this data? Number 7, looking at teen behaviors over the last 3 decades. So one's looking at vaping and cigarettes, one's looking at substance abuse, one's looking at sexual activity, television, smartphones, emotions and feelings, and things like, and so on, right? So take a look at these graphs. What conclusions can you make? Maybe again, what conclusions can you make? Why might we see this data? Or maybe what can we use this data for? Right? Things like that. The U.S. Agriculture Department model dietary plan. So this is what the U.S. Agriculture Department says, or their example for breaking up your weekly food plan, giving a price to it, so that you get the proper amount for your dietary needs, your average dietary needs. So this is how they're saying that you can break it up for a week. for a family of 4. And lastly, a little bit more of a fun one, looking at the number of, well, not the first part, but we'll see when we get to it, looking at the number of people who drowned by falling into a pool versus the number of movies Nicolas Cage has been in. So obviously not the drownings is the funny part, but maybe what conclusions we can get from it. So all of that, those graphs contain different types of data. There are different things we are looking at, different ways they were being represented. So categorical data is data that does not have a numerical value. Right? And these values tend to be more qualitative or have categories. Right? So we're looking at, again, like categories. You can still have a number in terms of like a frequency, right? How many people or how many individuals fall within a category, that's okay. But what we tend to see now is more the actual bars itself for the category. So if you go back to our probability distributions, the outcomes are the categories like red, blue, green, and then we have our frequency, right? So we can still have a value, but what we're breaking our data up into is more categories and then counting the number within the categories. So if we have categorical data, we tend to display it by using a bar graph or a circle graph. And within categorical data, there are 2 types. We have ordinal, which is categorical data that can be ranked in a logical way. Right, so maybe we're looking at, we'll look at some examples. Maybe we're looking at something like agree or disagree on a scale of 1 to 10, that type of thing, because those scales would be our categories. Nominal, that's categorical data that has no apparent order to it. So that might be something like comparing your favorite colors, your favorite types of food, your favorite sports teams, things like that. So let's look at 4 different examples and let's categorize them, right? Let's give them a rank, or not rank. Let's see if they are ordinal or nominal, right? Again, ordinal, think of there's an order. There's a logical way of arranging them. So number 1, to what extent do you agree with the following statement? And the statement is school spirit is present in your school. Strongly agree, somewhat disagree, or somewhat agree, somewhat disagree, strongly disagree. So this would be ordinal. Right? There is a logical way of ranking these. Right? So we would put strongly disagree on one side, strongly disagree on the other side, and we have kind of a good arrangement or a logical way of arranging them. Number 2, to what gender do you self-identify? Is there a logical way of ordering this? No. You're not going to put one identification higher than the other. Right? There's no logical way to really organize this. You're still looking at categories, but there's no logical way to order it, so this would be nominal. 3, your favorite sports teams. Right? So if I asked everyone what's your favorite sports team, is there a logical way to order it? Obviously, I put the Montreal Canadiens first, but after that, it doesn't really matter. Right? Joking aside, there is no logical way to rank it. Right? There's no team that's ahead of one or the other in terms of placement. Right? So this would be nominal. And lastly, characterize your use of recreational drugs, including marijuana, in the past month, ranging from did not use, used 1 to 2 times, used 3 or 7 times, used 8 or more times. So while there's not really a rank, there is a way that we can order this in a logical way or place it in a logical way, right? We kind of already see it done here. We see our different categories that we're using, right? Different groups. And we can see a kind of a rank to it, right? Ranging from 0, not using it, to more than 8 times. So this would be an example of ordinal. Now, both nominal and ordinal data can be displayed in either a bar graph or a circle graph. So we said categorical data can be displayed in a bar or circle graph. One thing we want to keep in mind though, if ordinal data is displayed as a bar graph, the bars should be in logical order. So if I go back to those two examples that were ordinal, I want to make sure they're placed in that logical order. Maybe strongly agree being on the right side because that's where we tend to have positive, and disagree is on the left. Right? Did not use is on the left side. We usually start off low and then we get higher. So what you can do, right, just in an example, I want you to try to look through and search and see if you can find circle graphs and bar graphs, right? So look through, Google it, or just search, see if you can find a circle graph or a bar graph and justify why we think that that data is either nominal or ordinal, right, depending on what we're looking at. So again, this could vary depending on what you find, but try to relate it back to, remember, ordinal, there's an order; nominal, there's no order. But we're still looking at categories. Opposite of categorical data is numerical data. And this is data that can be only collected in number form. So this is going to be, we're actually collecting numbers and it's specific values. And there's two types that we could look at, right? And we've kind of talked about these before, but the two types could be continuous, which is data that can be obtained by measuring, right? There's a possibility for infinite data points, where we talked about when you're measuring something, depending on how accurate your measurement tool is, there is an infinite number of data points that you could have. Discrete, that's data that's obtained by counting. And there's a finite number of data points. Right? There's only so many data points that there can be. There might be a lot, there could be a lot, right? But there's a finite number. An example could be like, how many days a week do you work? That would be more discrete, right? 1, 2, 3, 4, 5, 6, or 7. The other one, how long does it take you to get to school? That's measuring. We're looking at time. There's an infinite possible number of times that we could have, right? Again, depending on how accurate we are. Are we going down to the millisecond, the nanosecond? If we could, that gives us a lot of possible, or the possibility for an infinite data points. So let's take a second and let's try to classify the following examples as either discrete or continuous. So again, you've done something like this in the previous unit, but let's just kind of re-look at it. So how many days a week do you work? Right? We talked about that. That would be discrete. Right? We have only 1 to 7. Right? It can only be any of those numbers. You're not, maybe a half. Right? But if we're talking about days, it's just 1 to 7. How long does it take you to get to school? This would be continuous. We're measuring something. We're timing it. Right? So this would be continuous. Shoe size of high school students. Right? Discrete. Right? It can only be fixed values. 5, 5.5, 6, 6.5, 7, 7.5, so on. The last one, how many goals are scored per hockey game? Right? So this is discrete. How many goals are scored? Right? It can only be a fixed amount. Right? Looking at it, at one game, how many goals are scored? Right now, the Edmonton Oilers are playing the LA Kings, so you can kind of gauge that for time for when this was recorded. But 1 goal has been scored so far. Now make that 2 goals. Right? It's almost like they knew I was doing this lesson, right? So it wasn't like 1.5 goals or 2 goals or things like that, or 3.5 or 5.3, right? There's a fixed number of goals. When we're displaying numerical data, right, we can use a bar graph or a histogram. So we've used bar graphs before. That's what we use in our probability distributions. We used their histograms. We've seen bar graphs as well. So when we technically use histograms for continuous data, and bar graphs for discrete data. So this is, again, a little bit of a change and pace from what we did in the last unit, where we did use histograms for discrete data. That was more because when we look at continuous probability, we are using discrete. We are going to be using, histograms. So in general, continuous, we use histograms. Discrete, we use bar graphs. So again, as an example, what I want you to do is I want you to find an example of discrete numerical data by looking for bar graphs, and find an example of continuous numerical data by searching for histograms. If you want, go back up to the bar graphs and histograms, or the circle graphs, or the bar graphs and histograms if we had any, above in the examples that we used, and explain or justify why the data is continuous. Right? So there are some histograms, there are some bar graphs, there's one of each. So you can go back and look at those, justify why it's continuous or why it's discrete, and then state one conclusion from the graph. Or again, you can search and find some on Google. Another set of two terms that we want to look at is microdata versus aggregate data. So again, this is some more terminology kind of differentiating between the types of data that we have or that we're using. Microdata is individual data points. So we're looking at every single possible value, right? I can identify each individual in this study, in this organization, right? Looking at this, I can say, okay, I can see that I have 1, 2, 3, so many students. I can pick out individual students if I wanted to. I can see the actual times. Aggregate data has been summarized in some way where you can't know what the original microdata was. So maybe these values are important, or maybe I'm just concerned about the frequency in a specific range, right? So if I take those the times for the students or their commute to school in minutes, and I put it into a table like we see over here, right? I don't know what the individual data is. I know how many fall within a certain range, but I don't know the individual data points. So that's the difference between the two. Aggregate, I don't know the data. I don't know the original data. It's been summarized. I don't see every single point. Microdata, I can see every single point. Right? I can see every specific value. So that's the difference between the two. And lastly, one variable versus two variable data sets. So a bar graph, histograms, and circle graphs or pie charts, they all look at one variable at a time. We're all looking at one variable, whether it's going back to our examples, trying to think of them, whether it's the percentage of money spent, whether it is the price of eggs, or whether it's the ages of first-time mothers, right? We're only looking at one variable. How we record that might be different, might be percentage, might be frequency, things like that, but we're only looking at one variable at a time. If we're comparing two variables, two numerical variables to each other, we use a scatter plot. Right? So that might be the example of looking at the time it takes to get to school versus absences. Those are two numerical variables. Right? You can go back up and take a look at that example, right, and see how that compares to some of the other ones. Right? And we can kind of see that here again. Commuting times to school versus the number of absences. So we're looking at two sets of time. We're two variables, two numerical variables over time. Right? Or just not over time, sorry, just two numerical variables. Right? Looking at something over time doesn't necessarily mean two variables. Right? It might be in terms of how it changes over time, but technically we're comparing two things to each other, usually not time. Right? Time tends to be a line graph, and that's a little bit different from a scatter plot. Scatter plot is comparing two variables. So again, the main thing from this lesson is looking at the different types of data that we might come across and just how we can classify it. Because by classifying the data and understanding what type it is, then that determines what what type of display we should be using to represent it or to visualize it.